Hello, everyone. Welcome to another session of the Office Hours working session. My name is Dhruv. I'm a data scientist at Comet. For today's session, we are going to be going over feature engineering. So before we begin, I just want to point out some changes that we've made to our repo. So as you recall, in our initial repo structure, we had a file called data.py that we used to store all our data fetching and manipulation related. Because we're moving on to feature engineering, that process is going to become a little more complicated. So in order to isolate this functionality, what we've done is we've created a new branch called feature engineering. And within that branch, I've created a module, so a folder called data. And then within data, we have a bunch of files. We have profile.df. If you recall, that was the script we used to profile a data frame. We have features.py, which is the script we're going to use to extract our features. And then we have utils.py. So let's open up utils.py. So utils.py contains all the elements that were originally present in the data.py file, which is to load the data as a data frame, to fetch the dataset artifact from Comet. We've also added some additional methods or functions, such as upload dataset artifact. When we extract our features, what we're going to do once we have this feature data frame is we're going to upload this data frame as an artifact to Comet. So all this function is doing is taking in an input artifact name, creating a new Comet artifact, iterating over the files that we want added. So in this case, it's going to be a feature data frame for the training dataset and a feature data frame for the validation dataset. We're going to add these to our new artifact, and then we're going to log the artifact. The next function is the sample dataset function. So because we're doing feature engineering, an exploratory process, we don't really want to spend too much time trying to extract features from the full dataset, because we don't know at this point in time if these features are even useful. So the Hacker News dataset, the full dataset with the training and validation split, is about 1 million examples. So if we were to run our feature extraction pipeline on these 1 million examples, it would take a long time. So rather than doing that, what we're going to do is we're going to sample both our training and validation dataset in some smart way that preserves the score distribution between the sample and the full dataset. And then we are going to extract our features just in the sample. So this significantly will cut down our time to get into a feature and also our time to iteration, because if we want to try a bunch of models or run a hyperparameter search, fitting these models on a smaller data set will be much faster than fitting it on the full data set. And our hope is that between all the different model configurations and feature engineering techniques that we try, the relative performance of a selected model or a group of models will hold as the size of the dataset scales. So the model that is performing best on the 5% sample should perform the best on the full data sample. So to sample the dataset, as you all know, I'm working on a regression model. Is a continuous target. So how do you stratify, sample a continuous target or preserve the target distribution? So what we're going to do is we're going to bin our target using quantiles, like bin our target based on 10 quantiles. We are going to group these quantiles, and then we're going to sample from each of these quantile groups. And the idea is that the lower quantile groups, because our target has a long tail with most of the density being in the head, these lower quantiles will have more samples, and the higher quantiles will have fewer samples. So sampling this way would preserve the target distribution, and effectively, like, our sample will behave similar to our full data set. The next thing I wanted to talk about is the extract timestamp features. We're going to use timestamp as one of our features. So the raw dataset has a timestamp in the year, month, day, and hour format. We're going to extract these individual components as features. So we're going to extract the hour, the day of the week, the month, and the year from the timestamp feature and use these as input to our model. The next function is this preprocess function. So the preprocess function wraps everything, our full pipeline. So what we're doing is we are only going to use two columns to create our features. So we're going to use the timestamp that I talked about earlier, and we are going to use the title text as our input feature. So to turn the title text, which is a string, into some sort of vector, we're going to be making use of this pipeline object. So this pipeline object is simply a Hugging Face transformers pipeline for feature extraction. And we're going to use the Distilbert embeddings to create features from our text. So to create a title embedding, what we're doing is we're going to get a big list of text data from our dataset. We're going to iterate over the text data, run the pipeline that will extract embeddings for each of the words in the title. And then for all the words in the title, we're going to average them. So that's what this line over here is doing. So we're going to take the mean of a bunch of word embeddings that we've extracted from BERT and turn that into a single embedding called the title. We can call it title embedding. And that embedding is going to be our feature. So the BERT embedding has a dimension of 760 combined with the 5 features that we've extracted from the timestamp. This results in a feature vector that has a dimension of 773. And that's what is going to be the input to our model. Over here is just like some code to clean up the data frame and format it in a way that is useful. And then finally, let's go take a look at the features.py file, which is a script that we're going to use to actually fetch our input data, run the pre-processing pipeline, and save the output features as an artifact. So our input arguments are just the input artifact name. We also have an output artifact name. That's the name that we're going to give to our features. We have an argument for the pipeline model name. This is in case you want to change the model being used to extract the text features. You can use this argument to use any of the other Hugging Face models as your feature extractor. And then we also have pipeline batch size, which is if you were running on GPU, you could specify the batch size so you could extract these faster if you have a GPU with sufficient memory. And then we also have the sampling flag. So this argument is basically telling the script like how much of the original data set to sample when building these features. We're just going to go with 5%. So we set that as a default. And then finally, we have a random state, which controls how we sample the data. So we want this to be reproducible. So we're going to log the random state. So we have that seed that was used for sampling. And then finally, keeping in line with the project structure that we built, we're going to add a message argument that gives more context to this run. And the rest of the script is pretty straightforward. We're just fetching the data set, loading in the data as a data frame, and then sampling the data. That's what we're doing here. Sampling the data. And then finally, we talked about like how the sampling process preserves the target distribution. But just to make sure that we have preserved the target distribution, we're going to run this profile data function again, and that's going to use pandas profiling to profile the sample. We're going to log the samples to Comet so that we have an experiment that tells us that we can use to verify the sample data and the full data set roughly follow the same target distribution. So the next thing that we have to do is actually run the script and look up the results. I've already run the script. So let's jump over to Comet and take a look at the experiment.